Okay, section 9.7 is the last section we're going to talk about. It's on page 563. Talks about the binomial theorem. Now, the binomial theorem is something recent. Prior to that, we had Pascal's triangle. The goal is for you to be able to find a term. So, Pascal stated, and let me show you how this works. If you take x plus y to the 1, isn't that x plus y? And if you take x plus y squared, that is x squared plus 2xy plus y squared. And x plus y cubed, that is x cubed plus 3x squared y plus 3xy squared plus y cubed. X plus y to the fourth is x to the fourth plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the fourth. To the fifth, that is x to the fifth plus 5x to the fourth y plus 10x cubed y squared plus 10x squared y cubed plus 5x y to the fourth plus y to the fifth. And I'll do one more just for the heck of it. I could go on all day. X to the sixth plus 6x to the fifth y plus 15x to the fourth y squared plus 20 x cubed y cubed plus 16 x squared y to the fourth plus 6xy to the fifth plus y to the sixth. And let me elaborate on what I just did. I've been using Pascal's triangle. Pascal figured, look, if you take x plus y to the 0, well, that's 1. If you take x plus y to the 1, right there, you get a 1 and a 1. So x squared plus y squared, a 1 and a 1. And if you add those two, you will get the 2. That's how we get the 2. If you want to do x plus y cubed, you write a 1 and a 1. And you would add 1 plus 2 is that 3. And 2 plus 1 is that 3. So you add those two and those two. If you want to find x plus y to the fourth, so you write a 1 and a 1. You add those two, you get a 4. Add those two, you get a 6. Add those two, you get a 3. And that's what I did. I wrote a 1 and I wrote a 1. And 1 plus 3 is a 4. 3 plus 3 was the 6. And 3 plus 1 is the 4. And that's how I figure out all of this. If you add those two, you get this. And those two give you this. And those two give you a 20. And those two give you a 15. That's 16. My mistake then. That's a 5. And those two give you a 6. And how do you figure out the terms? Well, it's very easy. The way you start with, let's say here, you start with x cubed. And then you go 1 power less than 3, that's a 2. That means the y is going to pick up the 1. The power of each of those must be a 3. So this is a power of 3. 2 plus 1 is 3. 1 plus 2 is 3 and a 3. So I always start with the first. Let's go with this one, for example. I start with x to the fifth, the first term to the fifth power. Then I go 1 power less, which means the y has to pick up that 1, or must pick up that 1, so that we have a 5. Then 1 less than 4 is 3. That means that's a 2, because when you add the multiplies, you add the powers, you get a 5. Then a 2, then a 1, and then like a 0 power. And that's how I figure those out. The binomial is very useful to figure out one specific terms. The weakness of Pascal's triangle, if I want it level 600, I need to list the first 599 the first 599 levels to get to 600, which is a lot of work. Binomial could pinpoint a location one shot. It has two different forms. They're both saying the same thing. in case you don't know what this is NCR. This is n factorial divided by r factorial and n minus r factorial. And binomial theorem says if you want to find x plus y to the n, you start with x to the n, observe, and then n minus 1 and 1, n minus 2, just like we did, and you end up with y to the n. So you start with this being raised to the n power, and you start reducing that one at a time. The problem is not the variables, the problem is the coefficients. The problem is figuring out what these numbers are. That's the hard part. And binomial have a way of doing that. They say, here, always start with a 1, and choose 1, and choose 2, and choose 3, all the way, and again, and choose 1 is really n factorial over 1 factorial n minus 1 factorial. I'll show you how that works. Expand each binomial. So to expand the binomial, this is to the 6th power. If I really want to use Pascal's triangle, I can. It depends on the power. I suggest if it's 5 or less, use Pascal, and if it's 5 or more, use binomial, but you must learn both. So, if I want to use this formula, and let me show you how that works. This is going to start, this is what I know, it's going to be a to the 6 plus, the next term will be a to the 5 times b to the 1. Those must always add up to 6. Plus, a 1 less, 1 less, 1 less, 1 less, and b to the 6. So that's, okay, it was an erase. Oh boy. Okay, it's still recording. Good. Let me fix that really quick. What is going on? There we go. Very good. Alright. So let me elaborate really quick. That's normally how we start. So figuring out what the term is the easy part. The coefficient is the problem. If I really don't write it like this, if I go straight to it and write it this way. So notice, the first one you leave alone. This is going to be 6 factorial over 6 minus 1 factorial 5 factorial. This is going to be 6 factorial over 2 and choose 2. That is 2 factorial 4 factorial. This is going to be 6 factorial over and choose 3 and 6 minus 3. It seems to be a lot, and how are you going to remember all of this? I'll show you a nice trick. I have a lot of tricks up my sleeve. And the last one doesn't get anything. So a 1 at the beginning and a 1 at the end. Notice how I figured this out. The top is always 6 factorial. No questions about it. Now, do you see how this is 5 times 1? 5 factorial, 1 factorial. Do you see how this is 4 times 2? Since multiplication is commutative, you could put those in any order you want. If I say find a term, you could leave it like that. Or you could use your calculator. So on a test, if I say expand each binomial, that's all I want. And you could use your calculator, by the way. I do want you to practice this on the homework. And if I say simplify, you would find it. NCR is right there. And the way it works, if I go 6, NCR, 5 or 1 makes no difference. That's a 6. And if I go for this piece, 6, NCR 2. Again, 2 or 4 makes no difference. You could say 6 NCR 4. You'll notice you get the same answer. That is 15 a to the 4th b squared. How about this piece? 6 NCR 3. That is 20. So I'd like you to work that. If I allow you a calculator, I want you to work it out, and probably you will be allowed a calculator. This is identical to this. This is identical to this. And that's really what this is. And notice, I have that right there by using Pascal's triangle. Just that if you mess up on Pascal's triangle and you mess up on a number, you mess up the whole thing. On the next problem, I'm going to use binomial and Pascal's triangle. So again, be careful how you do this. When I want to do this, the key to the way we're going to do things, we're going to say this is the first term, 3a raised to the 4th power, plus, leave some space, 3a raised to the 3rd power, which means the 4b, the positive 4b, must be raised to the 1 power. Then the 3a raised to the 2nd power. So you always reduce by 1, and the sum must always be a 4. So that means the 4b must be a 2. The 3a, 1 less, that's a 1, 4b cubed. And you could say, if you really want, the 3a to the 0 power, but that's a 1, that's useless. But it fits under that idea. Now, that's the easy part. The hard part is the coefficients. We need to know what numbers go in. Well, I know the easy ones. This is a 1 and this is a 1. That's not a problem. What's going to go there? What's going to go there? What's going to go there? I could do Pascal triangle, but it's not as simple. So 0, 1, 2, 3, and 4. Add those two, that's a 2. Add those two, that's a 3 and a 3. Add those two, that's a 4, a 6, and a 4. There it is. Put a 1 right there, put a 4 right there, put a 6 right there, put a 4 right there, and put a 1 right there. That's how Pascal figured out what these numbers are. And that turns out to be the challenging part. And you could now say, well, 3 to the 4th is 81a to the 4th plus, and those, since you have a calculator, 4 times 3 cubed times 4. That is 432 a cubed b plus, and again, 6 times 9 times 16. That is 864 a squared b squared plus 4 times 3 times 4 raised to the 3rd power, 768 ab cubed plus 4 to the 4th is 64 b to the 4th. And that would be my answer. So I'm going to alternate on those. The next one I'm going to use binomial. I could use, again, Pascal. I suggest you learn both. And that's the big idea. Now, in research, when I did research, you only care about certain terms. You don't want all of them. You just want one term, which is whatever you're studying. So if I look at this, I'm going to use binomial on this. I'm going to say, well, the key for me to really do this, so I don't have to be stuck with memorizing the binomial, which is very messy, is for me to start with saying, look, this is going to be 2x raised to the 5th power. The next term will be 2x, 1 less, and that means the negative 5y will pick up the 1. Those must add up to 5 all the time. Then the 2x now cubed, negative 5y is squared, plus the 2x second, and that means this is the cube, 2x to the 1, negative 5y to the 4th, and a negative 5y to the 5th power. So, what's missing is the coefficients. If I really fill in the blanks, I'm looking at 5 factorial over 4 factorial 1 factorial. I'm looking at 5 factorial over 3 factorial 2 factorial. I'm looking at 5 factorial over 2 factorial 3 factorial. I'm looking at 5 factorial over 1 factorial 4 factorial, and this is a 1. And I'll get my calculator out and figure out all of this. And again, if I look at that second number right there, so this is 2 to the 5th is 32x to the 5th. Plus, to figure all of this out, do you see that that's going to be a negative because you have a negative raised to the 1 power? And if I take 5, choose 4 or 1 makes no difference, multiplied by 2 raised to the 4th times 5, I'm getting 400. 400 what? X to the 4th y. This is going to be squared, so it's positive, and I'm going to take 5, choose either 2 or 3 makes no difference, times 2 cubed, which is 8, times 5 squared, which is 25. And I'll get 2000 x cubed y squared, plus, now I'm getting to the next one, and that will be 5, choose 2 or 3 again, times 2 squared, which is a 4, times, oops, what happened? Times 4 times 5 raised to the 3rd power. That's 20,000, but 20,000 x squared y cubed. Do you see that this is raised to an odd power? That means that's not a plus, that's a minus. This piece, negative 5 raised to the 4th power is a positive. I'm going to take 5, choose 1, times 2, times 5 raised to the 4th power. That's 6,250. X, y to the 4th, minus 5 to the 5th power. If I don't allow you a calculator, you leave it as is. No harm done. That's 3,125. So if I don't allow you a calculator, your answer is right there. If I allow you a calculator, your answer is right there. For the homework, use a calculator. For the exam, we'll decide. Most likely you are allowed a calculator. And let's do one more. And this one I want to do using Pascal. Again, you could use Pascal or binomial on both. I suggest you learn both because I might ask you for both. Cubed. This is 0 power. This is 1 power. This is 2 power. This is cube power. Add, that's a 2. Add those 2, that's a 3 and a 3. So, this is the way it works. This is the first raised to the 3rd, 1 power less. That means radical 5b must be raised to 1. 1 power less. That means radical 5b must be raised to the 2nd. And radical 5b to the 3rd. And I'm going to copy those coefficients right there, right there, right there, and right there. That would be a to the 6th. There's a 3 there, a 3 there, and a 1 there. And this is going to be plus 3 radical 5 a to the 4th b, plus radical 5 squared is 5 times 3, that's 15, a squared b squared, plus 5 radical 5 b cubed. And that would be my final answer. Now the most important of those. This is the tricky part. Find the indicated term. And make sure you're doing what I'm doing, otherwise it's not going to work. If I want to find the indicated term, binomial is the way to go. So the way it works, the 4th term, isn't the first term c to the 5th raised to the 7th power? That's first. Second, third, fourth. Isn't this going to start with that 7 and start reducing by 1? Now, I already know how to do this. I really don't need those. I just need to figure out what that power is. Notice the negative 2d to the fourth must be raised to the third power. How do I know that? Those must add up to 7 every time. And don't you put in front of it a 7 factorial divided by a 4 factorial and a 3 factorial? I made that way too big. I'm going to shrink that just a bit. And I could leave the answer like that if I don't have a calculator. And if I have a calculator, I could do this on a calculator. 7 choose 4 times negative 2 to the third. That's 8. I'm getting negative 280 because that's negative. Negative 280. C to the 20th power, D to the 12th. That's the fourth term on the list. Do keep in mind, I always want a single term. I'm going to rewrite this really quick. So here I rewrote it. And that means negative 2d to the fourth must be raised to the third power. And that means in front of it, I must have a 7 factorial over 4 factorial, 3 factorial. And that's the term. And what if I wanted to do this piece? Now do keep in mind, one thing to keep in mind that helps a lot. The number of terms is always one more than the power. If I have a 0 power, I have 1 term. If I have 1 power, I have a plus b. If I have 2 power, I have 1, 2, 3. The number of terms are always one more than the power. So when I look at this problem here, I'll say, okay, you know what? This right here is 16 terms. I want the 13th term. 16. The last term is the 16th term. That is n to the 4th raised to the 15. The 15th term is the term before it. That's n to the 4th raised to the 14. Before that is the 14th term. That is n to the 4th raised to the 13. And before that is the 13th term. That's n to the 4th raised to the 12. So the last one will take the 15, and you're going to go one less. So if this is the term in question, I got it. Because the 3m, those must add up to 15, that must be 3. And in front of it is 15 factorial divided by 3 factorial, 12 factorial. That's the answer. And I could figure that out by plugging that in a calculator. I could say, let's take 15, choose either 3 or 12, makes no difference. I'm going to multiply that by 3 to the third. And I'm going to multiply that by, oh, that's a 1. So I'm getting 12,285 m cubed n to the 48. That would be the 13th term. Okay, I'm going to tackle the last couple of examples. So if I just write this, expand each binomial. One of them I'm going to use the formula, one of them I'm going to use the triangle. So let's go with the formula on this. If you say that's going to be 3 raised to the 5th, then it's going to be, leave some space, 3 raised to the 4th, then 3 raised to the 3rd, then 3 raised to the 2nd, then 3 raised to the 1. Why do I keep on making the same mistake? And you could think of it as 3 raised to the 0. Now, the negative 2i, you could think of it as negative 2i to the 0, negative 2i to the 1, negative 2i squared, negative 2i cubed, negative 2i to the 4th, and negative 2i to the 5th. That is, at any given time, those must add up to that. And that would be a 1 Here, I would have a 5 factorial over 4 factorial 1 factorial. Here, I would have a 5 factorial over 3 factorial 2 factorial, 5 factorial over 2 factorial 3 factorial, and 5 factorial over 1 factorial 4 factorial. Those should be backwards, but it's multiplication, and this is a 1. So, expand using binomial, I could do that, and expand using Pascal. Again, I'm showing you this. I need a fifth. I could go for a binomial. I could go for Pascal 1. That's a 0. That's first, second, third, fourth, and fifth. So you notice it's some work. If you go really high, add those two, that's a 2. Add those two, that's a 3. And a 3. That's a 4. That is a 6. And that is a 4. Add those, that's a 5. That's a 10. That's a 10. And that's a 5. So I need those coefficients. And I know this one here is, of course, you simplify the top and whatever that gets you. I'm going to take this right here and I'm going to say this is going to be, and if I follow, it's going to be f to the 3/4 raised to the 5th power plus, and if I start filling the blanks, so a 1 right there, a 5, that's instead of doing this, a 5 times, it's going to be f to the 3/4, so you start with a 5 and you go to a 4. That means the g to the 1/4 must be raised to the 1. Those must always add up to 5. Then a 10, f to the 3/4 raised to the 3rd. That means g to the 1/4 is raised to the 2nd, plus a 10, f to the 3/4 is raised to the 2nd. That means g to the 1/4 is raised to the 1st. And I really don't need those right here. I just need that bottom row. Plus a 5, and it's going to be f to the 3/4 raised to the, oh, I'm sorry, that's a 3. That's a 1, that means g to the 1/4 must be raised to the 4th power. And a 1 times g to the 1/4 raised to the 5th power. And you could multiply those, and whatever you get, that would be the answer. So you could do the rest, but that's an extra practice in case you need it. And there's the homework.